Hello, today we're going to go over some concepts in chapter 3. I'm going to share my screen with you, and we're going to look at pretty much the week 3 quiz. Let me see if I can pull that up. Let's see. Here we go. All right, so the first one, we have 10 questions. Chapter 3 is dealing with trig. First couple of questions is telling you to convert the angle in degrees to radians and express your answer as a multiple of pi. So we're going to convert 55 degrees to radian. And if we go back, I have some notes here. When you are converting from degree to radian, you want to multiply by pi over 180 degrees. So you have the 55 degrees. So basically what I do in order to end up in the radian, you want the degree at the bottom and you want the radian on top. And so the relationship between pi and 180 is 1 pi, 1 radian is equal to 180 degrees. And so now we have 55 over 180 times pi. And so when you simplify this, okay, you simplify it, then it reduces, so you divide by 5. They have 5 in common, and it reduces to 11 over 36 times pi. So this is how we get 11 over 36 times pi for that one. Okay. And so if we look, question 2 is the same thing, going from degrees to radians, same type of thing. Question 3, it says use the triangles given to the right to evaluate the expression given below. Express the value, if necessary, express the value without a square root in the denominator by rationalizing the denominator. Okay, so you are given, let's look at this. Okay, let's see if I can put this in the sketcher. Let's do a new. All right, so we have sine of pi over 3 times cosine of pi over 4, and then minus tangent of pi over 4. Well, when we look at the triangles, we don't see any radian forms, okay, right? We're giving the degree. I think the first one was a 45, 90 degree. So you have 1, and I think what the square root of 2, I think, here. And let's look at the second one. All right, and so the second one is a 30, 60, 90 degree angle. So 1, 2, square root of 3. All right, so let's put that in. Okay, so we got 1, 2, square root of 3. And this is 60, and that's 30 degrees. Okay, let me just back check, make sure. Yes. Okay, so now, basically, we're trying to relate this. So the best way that I can, or easy way that I can tell you about this is pi over 3. This is in radian form. I would convert these to degree form first, then we can relate it better to the triangles. And so we're going from radian to degree. So to go from radian to degree, then you multiply by 180 over pi, 180 degrees. So we have pi over 3. I'm going to multiply that by 180 degrees over pi. And the reason why we do that, we want the pi's to eliminate so that we end up in degree mode. So this is why we have 60 degree angle. And then for the pi over 4, multiply that by 180 over pi. Okay, and when you do that, remember these cancel, and we're just doing 180 over 3, which just simplifies to 60. 180 over 4, well, it should give you 45. Okay, so that's 45 degrees. So we got 60 and 45, which we can relate here. Okay, so now we can see it better. So sine of, and also remember the acronym SOHCAHTOA. All right, SOHCAHTOA. So, all right, let's see. Let me get my ink pen. All right, and so this is a CA. All right, so now we can relate this. And remember that the SOHCAHTOA, this is O, so opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. So let's not forget that. So now we can find out, okay, what is sine of pi over 3? Well, we already know that pi over 3 is 60 degrees, so we're looking at this triangle here. So sine of 60 degrees, okay, would be the opposite, okay, which is opposite of square root of 3 over hypotenuse. Hypotenuse is along the side, it's always opposite the right angle. So over 2. All right, so we have that. All right, the square root of 3 over 2. And now let's look at cosine. Cosine of pi over 4. All right, so pi over 4 we know is the 45-degree angle. So we're looking at this triangle, okay? Cosine is dealing with the adjacent over the hypotenuse. So it doesn't matter which 45-degree angle you look at. So if we look at this one, the adjacent to that is 1. Hypotenuse is the square root of 2. So we have 1 over the square root of 2. Now, what you want to do, now you have to rationalize your denominator. We have the square root of 2 to rationalize this. And I'll multiply the square root of 2 at the top and the bottom. And so that will give me the square root of 2 over 2, because the square root of 2 times the square root of 2 gives you the square root of 4, and the square root of 4 is 2. So we have that. Now, let's look at tangent. Tangent of pi over 4. Again, this is dealing with the 45-degree angle, so we're looking at this triangle here. Tangent is dealing with the opposite over the adjacent, okay? And so if I still focus on this one, the opposite is 1, okay? The adjacent is 1, so that's still 1. So now I just substitute what is sine of pi over 3, that's the square root of 3 over 2, times cosine of pi over 4, which is the square root of 2 over 2, and then minus 1. And so now I have to go ahead and multiply what this is. And I deal with the square roots, so that gives me square root of 6, because 2 times 3 is 6. And then 2 times 2 is 4, and then minus 1. Okay, and so we can leave it as that. And that will be your answer for this trig problem here. All right, and so it just says, see, the square root of 6 over 4 minus 1. Okay, so again, recapping that the way that I did it was I converted the radian to degree mode, okay, by multiplying by 180 over pi. And so I converted each radian to degree, and so we're dealing with the 60 degree and the 45 degree, which we're dealing with here. And so it's just a matter of, okay, which triangle am I referring to when I say sine of pi over 3? And so we knew we were dealing with the 60 degree angle, so we're dealing with this triangle. And with the pi over 4, we're dealing with the 45, 90 degree triangle. And so then it was a matter of knowing the trig identities. The SOHCAHTOA helps us to, to do the trig identities. Again, remember that, just in case, sine of your theta opposite over hypotenuse, cosine of your theta adjacent over hypotenuse, and then your tangent of theta is opposite over your adjacent. Okay, another way is sine over cosine. Okay, so these are some of your trig identities. Okay. All right. Okay, we're going to move on. All right, so that's that one. All right, now we have a problem to find the distance across a lake. A surveyor took the measurements in the figure shown. Use these measurements to determine how far it is across the lake. So we're trying to find out the length of A. Okay, so let's go back to my sketchboard. All right, so let me go back. And let's clear this. Let's do new. All right, so now we have, enter a picture. We have, oops. Okay. Okay, let's see if I can get it right now. Draw. Okay, pretend like that's a right, a right triangle. We have a 37-degree angle here. This is angle BAC, and this length here is 720. This one is the unknown, A equals. Okay, so we're in relationship to here. Okay, so some trig function of 37 degrees. Okay, has a relationship between of A and a relationship to this side here. So these two sides. So basically, this is the opposite. This is adjacent. Okay. And so what trig function does with opposite and adjacent? Well, again, let's write our acronym SOCA. So that really helps me. Okay, opposite of adjacent, so we're dealing with tangent. So let's do tangent. Tangent is the opposite over the adjacent. And so opposite is A, adjacent is 720. And so now we can actually evaluate this, okay? You want to make sure your calculator is in degree mode, okay? So degree mode. Because if it's in radian mode, you're going to get the wrong answer, okay? So when you do tangent of 37 degrees, you will get like 0.75356 approximately is equal to A over 720. To solve for A, then multiply both sides by 720. And so A to the nearest whole number would be 543 yards. Okay. And so that's how we do that. So it's just a matter of finding the relationship. What are we dealing with? Okay, we're dealing with, opposite, hypothesis, adjacent, hypotenuse. Okay, I'm mixing statistics up with trig. So my hypotenuse. Okay. All right, so that one's that one. Let's move on. All right, so let's deal with that one. All right, here. Now, notice, look at this one. This is the tower that is 106 feet tall, casts a shadow of 120 feet long. Find the angle elevation to the nearest degree. Now, this one, we're finding the angle elevation. The last problem, we were given the angle, but we weren't given this number here. So you see the relationship. We're still dealing with the tangent because this is opposite over adjacent. All right, so now look at this. Let me see if I can sketch that. Let's do another. All right, so let me. Okay. This time I'm finding the theta. This one is what, 120, and this is 106. All right, so now we're still dealing with the opposite over the adjacent, which deals with tangent still. So tangent of theta, opposite is 106 over the adjacent. So now we can find out what this is here. And so when you use your calculator, you get 0.8833. And so we have tangent of theta. Now to find theta, then you do the inverse. Okay, so inverse. So that would be tangent, the inverse of tangent, and you put, they switch places. So 0.8833 equals theta. Okay, and so when you put this in your calculator, you should have a tangent inverse button. And to find out what the theta is, to the nearest degree will be 41 degrees. Okay. All right. Okay. All right, here is something like this. Okay, if you have, let's write this out. Go to my sketchbook. Let's do a new. We have an inverse functions. The inverse of sine of the square root of 2, square root of 3 over 2. Now, this is equal to, I will say that's theta. Okay, now notice here, the last one we just did, they were reversed. So to find sine of, now, so what we'll do is we'll say sine of theta. This means sine of theta is equal to the square root of 3 over 2, correct? All right, so if the inverse of this, they just switch places, okay? All right, so now what we do is we know that we can just basically convert this to decimal. That's the easiest way. Convert to decimal form. All right, and when you do that, you get 0.8660. All right, and so we have sine of theta is equal to that, okay? And so now we'll know that the inverse, oh, we could have just, okay, 0.8660 is equal to theta. And so now, which we could have pretty much put it right here, the inverse, okay? I mean the decimal form here instead of going through here, but I just wanted to see the relationship. This is what sine theta is equal to, and we can relate that to, you can look at the unit circle to find out what the theta is. I mean, there are different ways, okay? And so when you do that, you'll see that theta is 60 degrees, okay? And see, even if you look at the unit circle, okay, if you're using a unit circle, remember that the ordered pair is cosine, comma, sine, okay? So when we look at the, let's just show you. Let me see if I have the unit circle. All right, so if we look at this unit circle here, okay, if you see the square root of 3 over 2, sine is the second coordinate, and so square root of 3 over 2 is here, and that correlates to 60 degrees. Okay, so that's just using the unit circle. Okay, so the other way that we did was we converted the square root of 3 over 2 to a decimal, and then we just evaluated that way. Okay. Different ways of doing it. All right. Oh, and so they wanted, okay, so since they wanted it in pi form, okay, so let's go back, because 60 degrees is in degree mode, so we can easily convert the degree to radian, and so 60 degrees to radian form, and that's pi over 180, correct? And so that would be pi over 3 in radian form. right, so good. So we got to be careful what they ask for. All right, so now, okay, that's that one. All right, here, I want you to look at this carefully, okay? And let's look at it. Let me let's look at it. We have tangent, the inverse of tangent, then we have tangent of pi over 4. Basically, what I looked at this as, okay, like tangent of, and this is equal to theta, right? If I look at this as converting it, okay, so if I know this is the inverse here, then I know they're going to switch places when I do the inverse of this. So that'll be tangent of theta will be equal to tangent of pi over 4. Correct? These would be equivalent. Okay? This is equivalent. So that means that theta has to be equal to pi over 4. You see that? Okay? And so that's the relationship between the trig and the inverse. Okay? When you do the trig and the inverse, you notice that this and this, they swap places. Okay? So the answer would be pi over 4. All right. All right, here, when you have something like this, we have cosine of 60 degrees minus 45 degrees. So that's dealing with the difference identity. And let's be careful with this one. The difference identity. Okay, so we have to know the difference identity formula, right? And so we're dealing with the difference identity. If you're dealing with the sum, then there's a formula for that too, identity. All right. And so when you're dealing with the cosine, okay, alpha minus beta, then the formula is cosine alpha cosine beta, and then it's the plus sine alpha sine beta. That's the formula. Okay. And so in this case, the cosine of 60 minus 45 degrees. So alpha 60, beta is 45. So we have cosine of 60 degrees, cosine of 45 degrees, plus sine of 60, sine of 45 degrees. So let's use your unit circle, okay? And it's already, if we go to the unit circle, all right, let's go to the unit circle. Right here. So we use this, remember that the cosine is the x coordinate and the sine is the y coordinate. So if we use the cosine of 60, that's 1/2. Cosine of 45, that is the square root of 2 over 2. Okay. And then if we use sine of 60 is the square root of 3 over 2. And then sine of 45 is the square root of 2 over 2. So we're using these two right here. Okay, so if we go back, okay. All right, so therefore I would have, like I said, okay, we said 1/2 times the square root of 2 over 2 plus the square root of 3 over 2 times the square root of 2 over 2. And now simplify, we got the square root of 2 over 4 plus the square root of 6 over 4. They have the same denominator, so we'll say the square root of 2 plus the square root of 6 over 4. Okay, so this is your answer right here. For some reason, if you do put it in this form and it does count it wrong, if you separate like that, you have to let me know, because sometimes it may just not accept this one for some reason, but they are equivalent. All right, so yeah, that's dealing with the difference identity. Okay. All right, so square root of 2 plus the square root of 6 over 4, or square root of 6 plus square root of 2 over 4, whichever. Okay, now. All right, this one here. This one's the same thing, okay? This is the difference, okay? Basically, what they want you to do is they want you to identify alpha and beta. So alpha is 62, beta is the 2 degrees. The cosine of the angle 62 minus 2 is 60 degrees. And then find out what cosine of 60 degrees is, and that's using the, just use the unit circle. Use a unit circle. Cosine of 60 degrees, then that's 1/2. Okay, so have your unit circle available. All right, and let's see what 10. Okay, 10 will come up. All right, so if we look at, all right, 10. All right, so we have this. You use the figure to find the exact value of the following trig function. So we have the double angle. All right, so basically we have to know, again, the formula for a double angle. And let's find that. All right, so if you do double angle for the sine of 2 theta is 2 sine theta cosine theta. So you can see a lot of this is just knowing what the formula, okay? What's the formula for, you know, the double angle? What's the formula for the difference identity, or the sum identity, okay? So since we know that, all right, let me do the triangle. We got theta, we got 17, 15, and 8. Now here, it does not quite have a right angle right here. So, you know, you're like, well, is this a right triangle? Okay, but you know, you can check it. All right, so if it is, it should, you know, by the Pythagorean theorem, the 17 squared should be the sum of the squares of these two, right? Okay, so if we do that, we can just verify that it's a right triangle. All right, so if we do 17 squared, that's 289, and 8 squared is 64, and then 15 squared is 225, that's plus, okay, and then 225 plus 64, 289. So right away, that is a right triangle. So we can go ahead and put our right angle right here because it is a right triangle. So now we have sine of theta. Theta, again, we have the SOHCAHTOA, okay? And we don't need TOA, okay? But opposite of hypotenuse, adjacent of hypotenuse. So that means that 2, and then sine of theta, okay, will be opposite over hypotenuse. So that would be 15 over 17. So that's 2 times that, times cosine of theta, which is adjacent. That's 8 over hypotenuse. Okay, so that's 8 over hypotenuse. And now all you do is you multiply. All right, so it might help you to put a 1 at the bottom. And so when you do that, you get 240 over the 289. So that's how you do the double angle. I hope this has helped. If you have any questions, please let me know. Okay.